started as you are here, and we take the opportunity of 4 minutes more. Sign, isn't it? Are you going to say something?
I have 4 minutes left to work.
Okay, okay, then you continue. But let me get it. In that case, okay. Let's start this one.
Doctor,
Yes.
may I show you the slides? I have prepared some slides for
Sure,
you.
sure. Yes. Your copy, yeah. Yeah, now 30? It's not yet. Then? Okay, let me ask you a question, both of you. How do you learn? How do you learn means not in a science. How do you personally pursue the path of learning? Say, for example, you are attending a class or you are attending whatever it be. So, what is your strategy?
I didn't get the question.
You didn't get the question? For what I'm saying. Say you are attending a class. Say this is for machine learning. Okay. So here I'm giving you say. and I am giving you some presentation and some reading materials. So, what is your strategy to learn the topic I am going to cover? Say, or even I showed you, like I discussed. Then, what is your strategy? How do you basically take the path of learning? Is clear or not yet?
I noted down the points. First of all,
No, but my question is clear.
I mean like
I think so.
Okay, fine.
for my case, I thought that machine learning is quite a tough thing, actually. But after the last class, when you go through all the points, I went through.
Going through all the points from where?
You
From
went
presentation?
through, from the presentation I went through it, and then I
How
searched in
much
the
time you
internet.
spent?
2 hours for the presentation slides.
You went through the presentation for 2 hours.
And 1
Okay,
hour for the software that
Okay,
you have
okay.
tell me to get used to.
Okay. So, okay. So this, like specifically for this one, you did like that way.
Yes.
Okay. But do you have any general framework, like how do you learn things? For example, a course, or how do you approach? The general, you will go to the presentation and then like.
I research the topics, just search it in the
So
internet.
before the class, before you coming to the class, you check that topic.
Yes.
Okay. Okay. Then.
Then I just note some points whether these things are easy for me or which are tougher I didn't understand, and then I try to I mean make it familiar with the slides that you will be going through today.
Okay. So how do you study in one stretch, for?
No, I'm
2-3
taking
hours?
breaks. Sunday I went through some slides, then in Monday I have went after classes. Then I went through some basic topics that I have confusion with.
But when you study, do you do multiple things or only one thing? Just you will have your email on, say everything, other things, notification on. Then you study, or how do you? But there is nothing good or bad.
I just
At
use
least I
using-
will not go to judge you. It's not mine. I'm just asking. Just trying to understand. So-
In my case, I usually open some research first of all. Then in the other side, I usually search in the Google, and in the research I usually look for the articles which are related.
No, but
with
I'm
the
saying that
topics.
when you work, do you keep everything on? Okay, you're checking something.
No, I'm not a multitasker actually.
But
I'm
how,
not good at
how
it.
frequently do you check email and then notification and WhatsApp and other things?
Email notifications, maybe after having gaps, after 2 hours of study, then I take a gap, and then I'm going through.
What about you? Would not believe this is personal thing. I don't ask. But in general, what is your strategy? How do you start it?
Okay, so this is I don't really have time now. In the bachelor it was different, but now it is.
Because you are working.
Yeah, so it's now a bit different. So in the bachelor, what I will be doing is that every day I will spend around 3 hours of studying, because if you study every day, then you don't have to study before the test, and you will be prepared for that. But now I don't have time for that, so I will spend around I finish work at 5 and I arrive home around 6, so I will spend the hours from 6 to 9 studying, the 3 hours studying or doing research or whatever assignment I have. And then when we have a test, I will be dedicated for that. I don't check my phone that often because I am used not to use it at work. So in the bachelor degree, I used to have switch off all the notification when I have anything. But now I don't have time to check it at work, so I am so used not to have my phone, not to do anything with it. So I don't check that much notifications.
But both of you, do you feel that the way you are the time you are spending and then the way you are learning, you are happy with that?
Yes. For me, the strategy is that learn everything here, so you don't have to spend time at home.
Okay, getting more engaged in the class,
Yes.
asking more questions. Okay,
Yes, get all the information you can from the class because you don't have time at home.
Okay, are you satisfied? The way you are learning, the time you are investing, and the way you are I'm not saying that performance. I'm not saying that, but in you are the way you're moving. Say for example, I'm saying that I spent 1 hour and then I managed like that. So you're happy with that, the way you're going?
You mean How?
Productivity. Let's make it productivity.
Like in terms of what I'm giving and what I'm getting it
Yes,
back?
yes. So you think that you are doing great. So great in the sense of, I'm saying not of the great, in a sense of time investment.
I think that like I am investing the most I can, so like.
But you don't have okay. So, but I'm saying that unit rate productivity means what? Say you have a study day, and then you are spending 1 hour and you are getting some output, and then you said, okay, maybe I can do better, same amount of time I will spend, but I will probably learn more. You got the point. So like if you have that feeling that no, the way I'm doing this is fine, I don't need to change.
Now, I want to think in my case, I want to utilize more time after Fajr. Like, I want to, but sometimes it's not possible. But I'm going in a seminar on the renewable energy these 3 days. So it was quite busy. From 7, I need to go to the building 54, and then I come from the seminar like from around 1. Then afterwards I having lunch, and then sometimes there are some teaching assistant work. So I need to do some
My question is that, no, my question is like that. You see, not in a specific scenario. I'm saying that in general, the time you're spending and then the learning you're happening for you. Are you happy with that? Like for example, what I'm saying that I am spending 3 hours. I feel that my 3 hours I should learn that much, but I didn't didn't learn in general.
I think I can spend less time and have the same productivity if I was not like perfectionist, then I would have less.
I wish I can give more time.
Okay. No, your idea is like more time and less time.
I don't feel satisfied actually.
Oh, your one is like in terms of investing time. Okay, but rate. What about the rate? Rate means productivity.
Yeah, like 10 out of something.
No. What I'm saying, productivity. You understood the productivity?
Yes.
Productivity. So I will if I say you and me, I'm spending 1 hour and you are spending half an hour, and then both of us learning same thing. So it means your productivity is more, my productivity is less.
Yes.
Okay. So my point is that if I'm in it might happen that what I'm doing I'm happy. Okay. In I'm 1 hour I'm learning and I'm happy. But in half, but some you might say no, I'm not happy. Probably I could increase my productivity. I'll spend only half an hour, but I will learn more.
Yeah.
Let me think for you. This is enough. Then okay. So this is why I discussed this, because there is big area. So how to learn? Okay. So how to learn? It itself is interesting. There is one famous course in Coursera by Barbara Watley. She is a famous electrical researcher. But she started with his life with not engineering background. Very late in her life, she started, and then she did quite well in engineering. So she gave some really interesting insight. You can follow her course in the Coursera, and with the free version you can have a look. Anyway, there are other some for example, visual note taking, memory technique. There is other big areas which can help. This is up to you. But just I am trying to put it there is an interesting area. Okay, so you have something to present?
You said we can present from your slides.
Sorry?
You said
Okay, from yes,
yeah,
sure.
from your slides.
Okay, so Mustafa, maybe you can go.
Last class,
You can make what you call presentations.
we have covered a lot of topics, but I have went through some. I found this quite much useful. It's from the University of Toronto, I saw. So I just went through some topics. So in case of machine learning, we means actually it's a process by which a system systematically improves through supervised or unsupervised or any other reinforcement learning. So by machine learning, we mean from the quotes of Herbert Simon, we mean the learning is any process by which a system improves performance from experience. And also from the definition by Tom Mitchell, he says that machine learning is the study of algorithms that improve their performance at some task with experience. So it's a well-defined learning task which is given by the three terms like performance, task, and experience. So in case of traditional programming, we can see that it has two types of program. One is machine learning and the other is computer programming. In computer programming, it means like basic C++, or these are the computer programmings, and the other system is like machine learning. We input and output the data and we get the programs. So why when we are using the machine learning, basically we use the machine learning in 4 types of general prospects which are on human expertise, does not exist, navigating on Mars, speech recognition, personalized medicine, and genomics. And also it says that the learning isn't always useful. There is no need to learn to calculate the payroll.
Why?
I mean, like the terms is the machine learning things is such type of things that it's done by the machine. So we human don't usually need to learn the things by our own self. We just giving the.
Even can you explain what it means? Learning is not always useful. Then there is no need to learn to calculate payroll. What does it really mean? Just whatever you feel. There is no worries.
You don't always need to learn things to do it. Like learning, like if you have so many information and you are learning so much, so what would be the use of that? It won't be useful always. So in order to calculate the payroll, it is like simple thing. You have a sheet and everything. Like in a company, especially, they will have a program. So you just need to write specific things, small things, and you will get the payroll for that person. You don't need to know how they are calculating the salaries and everything.
In fact, you answered correctly. Then another part is not essential. Like the way you said that, this is a trivial job. It's like you add it and subtract it, then this is the payroll system. You'll get your bonus, you'll get it used over time. This is as simple. This is a well-known structure. There is no issue of learning. You plug and play. So this is so there is no issue of learning. So the issue of learning is coming in some places, not everywhere.
Okay.
So, and then this problem is like you are calculating. There is nothing is hidden. We know basically how it's completely operating. You got the point. But if you tell me how do I recognize this birds and what do you call for example images or looking at, this is another issue. We cannot explain. But here we know it, the process exactly. So some places machine learning is not useful. No need probably.
Yes.
Yeah, proceed.
So some classic examples, suppose we understand some terms here, like 4, 5, but some terms are very much hard to understand. So a machine can also feel these terms like these are very tough for understanding the purpose. So
here, this kind of issue is for example, this sometimes as a human being we can do that, but it is difficult for us to transfer the knowledge to a machine. But if it's the machine learning, it will be able to understand from the example, and it can be used as a system, like automated system. You see, no need for intervention. Okay, and it's not a structured learning. You just give example, he will understand. So for example, if it's what you call text, here number recognition, we don't care how he is doing it. If he's giving all his good result, we are happy with that.
shall I proceed?
Yeah, please.
So some examples of tasks that are best solved by using a learning algorithm. These are recognizing the patterns, generating the patterns, and recognizing the anomalies and the predictions. So for recognizing the pattern, we see that the facial identities of our facial expression, handwritten or spoken words, medical images. For generating pattern, we see the motion sequences, and for recognizing anomalies, we can see the unusual credit transactions, unusual patterns of sensor readings in nuclear power plant.
Now stop here. Both of you now, you share and then say that. Do you have for each of them? Do you have any example from transportation engineering or planning?
Yeah.
Discuss and say if can Ivan can help him or you.
Recognizing patterns, maybe it is related to if we have a peak hour or something, we would have
Okay, fine.
Peak hour case, yes.
Fine. At least in a peak hours, in a say big area. Big area. It's not like in specific only like for one segment of a row. So it's like okay, fine. And then generating patterns.
It will know that in this time there will be some traffic or something.
Generating image or motion, generating patterns, generating images or motion sequences. Probably it will help you in autonomous vehicles. Okay, if you understand that how the trajectory of other vehicles. Okay, because now there is a new approach of like what they call not signal timing optimization. You just take care of if you imagine all the vehicles are like autonomous, then probably you don't need a signal. You just need to know the trajectories. Okay, because it's not human being that he will get scared or not. So it's fine. Like you might feel it in heat, but it will not. So you know the trajectories. All the trajectories are known, shared. So they will make maneuver. Fine. Recognizing anomalies.
It's like
But yeah, okay, you understand the concept, isn't it? Unusual credit card transaction, for example. So here it can be a special case, accident.
accident cases. Yes.
Crash.
Prediction is like crash predictions or
Yeah, crash prediction, traffic flow prediction, there are many things. I think, yeah. Even the trajectory prediction. Yeah. Fine. Yes.
so simple applications such as web search, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks, debugging software. So I think this is out of our topics as you discussed.
No problem. Yes, I said fine, it's okay.
Here, symbols checkers play. It means the machine learning. It's a field that gives the computer ability to learn without being explicitly programmed. So, I mean, like in the chess players, we usually see the games like in computer screen when we usually play the jobs. It's a machine learning process that it is automatically done, but we humans usually play with the chess players in the computers. So I think I can relate this with the machine learning thing.
Yeah, but in the machine learning, what is they're doing? This is a bit different. Like here, he is not. He does not know what move you will give. You can give any say you can make a very stupid move. Like you may say, for example, I can make a very stupid move. Okay, so then he has to make a he has to have a strategy to answer it. So this is sometimes the unknown. So this could be reinforcement learning. It could be like what you call. It can be reinforcement learning, or say what you call this can be what you call. It can be it can be say reinforcement learning, and another thing is like for example, this is another thing they call it generative adversarial network. For example, generative adversarial network here. Like this for fake imaging and for some other purpose. Here you can say reinforcement learning probably. Yes. Yeah. You can.
Defining the learning task. At first, we need to improve the task with respect to the performance metric based on experience. So suppose here, as we have the three terms like T, P, and experience. So for the T, we see that the playing checkers. For P, usually describe the percentage of games, and the E demonstrate the playing practice games against itself. So there are some examples that we have seen from the three terms. So
okay, fine, no problem. You can proceed.
So state-of-the-art applications of machine learning. So for in case of autonomous vehicles, we can see that Nevada made it legal for autonomous vehicle to drive on roads in June 2011. As of 2014, 4 states, Nevada, Florida,
You can
California.
proceed. Yeah. This one is clear. No problem. Autonomous car. Yeah, it's fine.
So technology. So facial.
But this one you want to explain or what?
This thing I have just seen that the facial recognition that it prescribes in one of the part of the.
Okay, I'll just explain it briefly. This is basically a convolution neural network. Okay, this convolution neural network is used for computer vision. Whenever you say the computer vision, it's related with like something you can like the way we see it, maybe the machine can see, and then they can tell about, they can understand what is happening. Okay, so in the convolution neural network, you don't need to understand like for example, you give an image, give any image, you don't need to tell him that okay, like please take the what you call contrast, take this and that. We call it features. Then make it no. He himself will take the decision. You just need to say something filter, some filter drop out. So this is basically for deep neural network. So what is happening here? Features you don't need to give explicitly. He will understand by itself. You see the way the image is getting. It has like very important. Yeah. What is happening? Whatever the image is like that. So what she is doing, like what the software like deep learning is doing, is just finding out the edges. Where is the contrast? So it's like some high level understanding. You see your eyes, your nose, here. So even if your object is separating, and then he is going slightly, some more details. Then finally he is deciding about that, like it's coming with something like that. But the interesting thing is that you are not telling him to do that. You are just using some filter. Filter, like for example, you take 4x4 matrix, and then you take the minimum maximum of that. That is max pool. Okay. So anyway, the main idea, what I want to understand, like tell you that if you want to use something, this is for image recognition, or in fact it can be used in many other areas. But the idea they usually explain is that image recognition. So this is a convolution neural network. Okay. Anyway, you can proceed this. That's it. Yeah. But there is one interesting thing. At least if you know, maybe if you need, sometimes you can use. Say you have they call it pre-trained model. Say YOLO 8V, YOLO 7V. What is this? They use millions and billions of images. Okay, and then they train a deep neural network. Means many neurons, many hidden layers and many neurons. So what will happen? And then these are some weights, some of the weights. So he learned how to differentiate even different, like many different kinds of things. So what you can do? I will take that model by using application like a programming interface. So I have this one, and I will train it with some small data. Okay, some small data. So what it will have? Because what is that? It means that someone is experienced scholar, like intellectual, and then I tell him that as he is intellectual, he will be able to understand something else very quickly. So here I will not change his whole like structure. I will just change the last layer, for example. But it's not if something is available for not for everything. For example, ChatGPT is not available. You can use ChatGPT, but you cannot use the original model of of the ChatGPT. But there are for image classification, you can get the pre-trained model. So what did you like? For example, you have a generic what do you call model, this pre-trained model. But now with your information, this model will slightly change. So it's like personalized for you. Yeah. That's what is happening. You tried any software like DTRAG or? Yeah. Okay, complete, no problem.
So automatic speech recognition, it can detect a person's speech whether for identifying things.
Even by the way, you can make it now. When I say the generative adversarial network, what it does, it will take for example, the way your speeches, and then it can play with that. It can make a fake, like a fake speech, what you didn't say.
Yes.
So this is called generative adversarial network, GAN. But we can use it very positively in many ways. How do you do it positively? Say you have to generate new data. So you have a model. Earlier, if you don't have good number of data, say even for the problem you are discussing, say you don't have much data, so you have a small set of data. Okay, then you can use generative adversarial network to generate information. But in that case, you have to be careful about one thing. Training set, you have to separate it. Say that okay, I have 100 data. This 20% I am going to test my model. This 20% I will not let it show. But let's see that 80% I train the model. It's not doing well for the testing. But what I can do, this 80% now, I generate maybe 200 data using GAN, generative adversarial network. Then I see, am I doing well for for the testing data? So there are, at least I'm not expecting that you will understand fully, but you understand what can be done. So if you need, when you need, for example, for your thesis, like a dissertation, so you can, if you have to work, then you for sure you'll be able to understand and implement.
Effect of deep learning, speech technology. These are the
Fine.
so types of learning as we can discuss. We have discussed in the last class: supervised learning, unsupervised learning. There is another learning is semi-supervised learning, and the last one is the reinforcement learning. So
Okay, you can proceed. I will ask this thing. Classification, okay, fine. Yeah, you can.
Shall I proceed?
Yeah, proceed. So this is classification problem. Okay. You understand this reinforcement learning?
Yeah.
But it is not main focus. Just you can like you can understand that some agents are there. So agents, they have some rules, so they will understand from the environment. So they will learn from the environment.
Yes.
It can be for robot. It can be some, what is it called? Some hazard, maybe it's like what do you call a difficult place to go. You can just throw some sensors. The sensors will communicate. If it's a small robot, they will take their actions, maneuver, and then they will collect information. Okay. But reinforcement learning you can also use for traffic signal optimization. Okay, traffic signal optimization. There are some uses I saw.
So agent environment interface is the thing is like there's an agent in the environment. So from the environment we get two types of outputs, and from the agents we get the actions. And this is the overall rotating procedures. So here we can see that the formula that they have used, just the concept I can just understand, but not.
So like agent, he's getting the state of the information. what is the condition of the environment? Then he will take action, and then if he get reward, he will keep doing. If he gets punishment, he will not do that. Okay, as you can see, simply understand like this way. No problem. Yeah, proceed. Okay, you can. I think no problem. You're not focusing. You can skip, no problem. Okay, you can proceed.
So it's finished.
Yeah. Okay. No. Go back. Yeah. Go back. Yeah. What is this?
It's various optimization algorithms. Different types of programming languages in the machine learning.
No, it's not programming language. This is like optimization algorithm. Okay, fine. Proceed. Like this is gradient descent. This is used for neural network. Dynamic programming. This is hidden Markov model and PCFG model, decision tree index. Okay, fine. You can proceed.
These are practices and the lesson learning for the
So you check any software?
just
You tried D-Track?
D-Track.
How is it?
It's easy.
Easy?
Yeah.
It's like okay.
Not so
Fine. Can you can you go for presentation slide? Yeah. So how much time you spend for D-Track?
Only just 1 hour.
1 hour.
Practice more.
So but in 1 hour you implemented
I
it.
just just practice the decision tree, how it is.
So okay, fine.
So this is the steps that in the main screen that
Yeah.
we get. So we create a new project with a model, and then we set the options and enter the registration key. Just
Fine.
I don't have the registration key, so I can.
Third case.
So then afterwards, we can see that to set the track preferences, we just click on the tools. There is a tools option. Then afterwards, we select the preferences from the drop down. Then we create a new project and click the icon. Just click on the options. And afterwards,
you put the data.
we can see that after inputting we can create generate a new normal predictive model, single tree. Then we specify information about the variables. We just select some items like predictor, categorical, and target. Then afterwards, we just give some values in the next one.
Yeah,
Tree
it's the
depth.
tree depth. You know how many layers you have.
Yes. So after that, we get the data from here. It's a decision tree.
So it means that you use a lot of depth. You should not. Just the two depth is fine.
Yes.
Depth of 2 is fine. So what it is predicting? You say species is predicting? Yeah, species is predicting. Okay. From the petal length, is that okay? Okay. So you use a decision tree. So what's your feeling after using that?
Yeah.
So did anything come in your mind that okay, you can solve any problem for you, like for any course or anything, you can use decision tree for solving the problem?
Maybe
But anything came in your mind? When anything came in your mind for solving any transportation problem?
For now on,
Okay.
I hope inshallah.
So now you can, what you have to do now, you can just search, see how the different types of decision trees are used for what kind of transportation problem. So you can search in that line. Okay.
Thank you so much.
This is really good, great experience. So it seems that okay, you can at least in this one day, if you can, if in one day you can use the decision tree, this I think is fine. So Iman, you want to show something?
You said you can go through the slides and present
Yes,
your
you
slides.
present in slides if you can.